We talked a lot about unit conversions and about sort of the algebra way of finding mass and moles and number of atoms. And the way I learned in high school was that you used formula plug answer to find what you wanted to find. So if somebody gave you like a number of atoms and said how many moles was that, you'd use that top equation, moles equals number of things divided by the mole number, and that would be your answer. I'll also show you guys how to do just unit conversions, and either way works. Either way requires that the units cancel out and give you the units you want, and if they don't, then you're not doing something correctly. I would recommend that you have these on hand in case you're like me and you panic on tests. But ultimately, unit conversions in algebra are very, very useful. We covered the mole number. So a mole is 6.022 times 10 to the 23rd. And you can get more decimals on that. Although I apparently can't look them up fast enough for you. But you can. So it's not exactly that. That's not a definition. There's more numerals. I just truncated it. The atomic mass, you can think of it as having units of atomic mass units. I didn't stutter. That's what I actually meant. AMU, or atomic mass units. Or you could also think about it as grams per mole. I think that was worth saying twice. So let's consider just sort of going through the motions and balancing reactions from beginning to end. If somebody says, I took two solutions, one of iron 3 chloride and one of silver sulfate, so clear water solutions of these two salts, poured them together, and then I saw a precipitate form, just some solid line the bottom of this new container. Give me a reaction for that. And at this point, I think you guys should be able to do this, especially with the aid of a book. So, or your notes. So the first thing I would do is I'd figure out the formulas of the reactants, because I didn't actually list them. They're there in English, but they're not there in chemical formulas. So chloride is Cl minus, and iron 3 is Fe3 plus. So I gave those away. So you should be able to write a ionic compound formula from iron 3 and chloride. So you balance the charges. There's 3 -1 charges for the chloride. You know that chloride is -1 because you look at the periodic table. You see that chloride is right next to the noble gases. It's a nonmetal. It just takes one more electron to make it have a noble gas configuration. So it's going to be -1 as an ion. And you know that iron 3 is 3 plus because that's what the 3 means. It means 3 plus. So it'll take 3 -1 charges to balance that +3 charge. So it's going to be FeCl3. And that's the neutral compound you'd write in the chemical reaction. And that was really long-winded, but it's actually a lot more elegant as a process, as you all know now, because you've been doing ALEX and you've been doing midterms and clicker questions, and you're tired of hearing me talk. But it is pretty straightforward, and you have the periodic table as your treasure map to figure out what's going on. Silver is +1, and sulfate is SO4 2-, and you could have looked up in the book that silver is +1. In this class, it's going to be +1. If I ever make it be 2+, you should come yell at me and say that, hey, wait a minute, it was never 2+, and it's not appropriate for this class. Sulfate is that. You can look this up in the book as well. It's SO4 2-. Those are the two ions that we're dealing with. So it takes 2 +1 charges to balance the -2 charge to make it overall charge neutral, or a 0 charge overall. So that means that Ag2SO4 is the formula for silver sulfate. Does that make sense, or does anybody have any questions about how I did that? Yes?
Do we have to just memorize a lot of the different symbols that are different?
You don't have to, in the sense that you won't be, in this class, required to know them on an exam. You'll be able to use your notes, use the book. So there's a list right there on the first page that isn't like a hard page, table of atomic masses. Like there's elements and there's symbols, and you can use that if you want. I would personally try to be acquainted with things like sodium that is Na, just because it's like fast. But I printed out, and you can find for yourself, a periodic table with the names on it too. So whatever you're comfortable with, right? I don't think that it's meaningful, and by the way, you're welcome, to make you guys memorize stuff like that. I want you guys to know how to do the balancing stuff, but that silver is Ag. Just bring it in your notes if you don't want to memorize it, okay? The world is your oyster. It's your world. I just test you on stuff. You can't ask your neighbor, though. You can't be like, "Hey, everybody, what's NA mean?" Okay? I wouldn't like that. Okay. So again, given this description of what happened in the reaction, you should be able to figure out what the compounds that would form or could form are. So you know that the ions for silver sulfate are Ag plus and SO42 minus. So you should be able to come up with a neutral ionic compound that comes from mixing up those ions with the ions from the other reactant. So you know that the cations, the ones that are positively charged, are going to have to be balanced by ones that are negatively charged. So you would put together, well, what would iron be? It could be iron sulfate. We started with iron chloride. That was the starting material, the reagent or reactant. As an aside, and every time I make an aside, it means I have to edit it out of the YouTube clip, so it sucks. But I'm doing it because I really want to have you guys have a good educational experience, and apparently I like making work for myself. But yeah, so just so you know, I'll use the words reagent and reactant interchangeably. In real life, they're slightly different. So a reagent is like anything you mix into like a chemical reaction, anything you add, start with. But a reactant is more like a piece of something that gets worked on. So like when you take your car to get like painted, the paint would be like a reagent, but the car would be a reactant. But I'll just use them interchangeably, so just assume they're synonyms for this class. All right. And when I say product, I mean like the thing that gets made in the reaction. Okay, so not only should you be able to tell me what I started with based on the description, but also you should be able to tell me what the possible products would be based on just swapping the cations and anions. So you should be able to give me that there's silver chloride and that there's iron sulfate. And you should be able to show me that this is the right compound. So each iron is 3 plus, and each sulfate is 2 minus. So you use that crisscross trick to guess that this would be the formula, and it works out because 2 iron 3s is 6 plus, and 3 sulfates is 3 times negative 2, so that's 6 minus. So this whole thing has a neutral 0 charge. Okay. The next thing you should be able to do is you should be able to look in the book or in a list of insoluble or poorly soluble salts and see that silver chloride is really poorly soluble in water. So the precipitate, you should be able to identify it as being silver chloride. So what this whole thing looks like is that you started with 2 clear solutions of salts. You poured them together, and all of a sudden, like some cloud of junk appears, and it falls to the bottom. That's the precipitate. That's the silver chloride. The stuff that's in the powder, that's the silver chloride. And then the liquid stuff, it's not clean. It actually has salts in it. It has the iron sulfate in there. So actually, the iron would be iron 3, and it'd be in solution, probably coordinated by waters. And the sulfate would be surrounded by waters as well, and it'd be sulfate 2 minus. So this would be ions in the solution, and this would be the precipitate, the powder that falls out of the solution. And there you go. So you guys actually have all the tools now to start predicting reactions, showing me what they are, and you know, if something happens and I show you these 2 solutions, you'll be able to say, oh, that powder is silver chloride, that stuff isn't just water, there's ions in there, and most of those ions are iron 3 and sulfate 2 minus. You should also be able to show me what the state symbols are. So AQ means aqueous or in solution. S means solid. So if somebody says precipitate, that means solid. And if AQ, it means solution. G is gas. And if you make water and it's in a water solution, you should call it L for liquid. And now that we have this reaction, it does not appear to be balanced, so we'll balance it together. We have how many irons? We have 2 irons, and we have just 1 iron over here. So how do we fix that? How do we get 2 irons in the reactants? Put a 2 there. Great. Okay. So how many chlorides does that mean there are now? 2 iron chlorides, that means 6 total. Great. We have to fix the chlorides over here. So if there are 6 in the reactants, how many do there have to be in the products? Hooray! And how do we do that? Yes. So 6. There we go. What do I have to do over here? There's 6. Add 2 to make 3. Yes. Doubly right, everybody. We get... Yeah, sometimes semantics will matter on exams and stuff, but when it's questions and answers, I can kind of guess it, what you mean. Okay, so how many sulfurs are on each side now? How many oxygens are on each side now? Yeah. How many irons are on each side now? And how many chlorides are on each side now? So I think this is balanced.